You know, yesterday we talked about the concept of square meters and square inches and all that stuff, and how to create a conversion factor for that. So let's do one with cubic. Okay, so 49.3 is given. Trying to calculate cubic meters. Now, cubic is three-dimensional, like this box. Square is flat. And then linear is just a line. Okay, I want you to make sure you understand those three levels of conformity or confirmation. Okay, so we need to go from inches to meters. We can go inches to centimeters. Centimeters to meters would probably be the most correct. Now, problem is for the given to cancel, it's got to be cubic. So that means we have to cube everything. So when we do the calculations, we're going to go 49.3 times 2.54 cubed. Now, if you want, you can just do the cubed on the side and put it in if you want, either way. Okay, so that gets us to cubic centimeters. Now let's go from cubic centimeters to cubic meters. Now, centimeters is like cents in a dollar. So there are 100 centimeters to 1 meter. And we want to cube everything so that things cancel. Okay, does everyone see why we have to cube everything or square everything? Depends. Okay, so 3 sig figs. This is define and define. So we're looking at 3 sig figs. That's the answer. So we're looking at 807. 808. Again, setup is 90%, 10% for the answer. Now you're going to have one of these on your tests. Maybe a cubic one and a square one. Okay. On lab 2, there are some practice problems. Ignore the little explanation on lab 2. Put your hand up. Okay. Okay, so on lab two towards the end, you're gonna have a problem like cubic or square, I forgot which one. And it explains in the little paragraph how to do it. Ignore that. It's very confusing, in my opinion. Just go by what we're doing here. Everything's got to be cubed if it's cubic. Everything's got to be squared if it's squared. I mean, you can't be any clearer than that until you read the little explanation. And it's like, right, so just. Okay, so what was your question?
So you left it as cubed. Like you left 2.54 cubed and then 100 cubed.
Yeah.
If I converted that into what the actual number would be,
That's fine. That's what I was saying earlier.
but I got a different answer than you. I got 5.21. Would it change if I?
No, it should not change at all. Well, let's do it your way. Let's see here. I've been known many times to make errors, so. All right, so we're looking at $254 cubed is and the problem by doing this, you shouldn't be rounding. You should round at the end only. Otherwise, you get rounding errors. Well, but anyway, so as many digits as you can fit in there, put in there. Now I get the same answer.
I think where I messed up is I rounded 2.54 cubed. So
Okay,
I was like a couple of numbers off.
okay, but when you're doing that, put as many of those in as you can. And that'll it'll there's gonna be a little bit of error. Because if you do it 2.54 cubed, your calculator will keep all the 29 sig figs there. But by you doing it like you're gonna significantly reduce it. So you're gonna get a slightly different error of out. But if the sig figs will probably get rid of it anyway. Does that make sense?
Yeah, now I see where I went wrong.
Okay, so anyway, that's an example of two ways to do it. Okay, all right, whenever you're working with speed, it's always a fraction. When you're working with money, you always have two decimal places. No exceptions. Money's weird. Sometimes you'll have one sig fig and you've got money, so you've got to extend it out to two decimal places. And teachers have various perspectives on that. With me, it's money. Money's always in two decimal places or no decimal places. Like the government works in, they don't even talk about thousands of dollars anymore. They barely talk in terms of millions of dollars. It's billions of this, trillions of that, like crazy, crazy numbers. Unfortunately, for programs they are cutting, also millions and billions as well. Okay, all right, so given is 34 miles per hour. And we're trying to convert to meters per second. So fraction problems, I was telling you yesterday, are really two problems. There's the numerator and the denominator. Okay, denominator, we're gonna go from hours to seconds. Let's do that one first. So let's convert. Remember, the given always has to cancel, so it means hours on top. And we're gonna go to 60 minutes. And then we're gonna go okay, now we got seconds on the bottom. Now we need to work on miles to meters. Okay, so miles to meters. Well, we can go a mile in a kilometer. Notice it's not boldface, means that is 4 sig figs, not infinite. Okay, once we're in kilometers, and we can go kilometers to meters, would be the most direct way. Now you can also go to feet and go feet to inch. I mean, there's a lot of ways to do it as long as you're careful on your unit cancellation. It'll all work out. But the most direct way would be convert the miles to kilometers, kilometers to meters. Yeah. You fixing your hat. Okay, so we're going to go miles to kilometers. And I cleverly forgot. I have more conversion sheets for anyone who did not pick up a conversion sheet. Everyone okay with the conversion sheets? Well, I'm gonna have one out. Instead of keep going back. Okay, it's 1609. What I forgot.
It doesn't matter which one we do first, does it? Like we could have done hours to kilometers first and then seconds after.
Yeah, it doesn't matter the order because in algebra, multiplication is cumulative. So 2 times 4, 4 times 2, same thing. Everyone hear this question? He asked about the order. Does it matter which one we convert first, the top or the bottom? Doesn't matter at all. Whatever suits your fancy. Okay, now we're in kilometers, we need to go to meters. Okay, so everything cancels except for meters per second. Okay, so we have 3 sig figs, infinite, infinite, 4 sig figs, infinite, so our answer is going to be 3 sig figs. if she comes in, she has an accommodation to set up front, besides making it stink about it. Okay, how many cubic inches are in 1.5 cubic kilometer? Again, it's a cubic one. So we bring in the cubic conversion factors. So we're going to start with 1.5. Do I need to cube the 1.5? It's already been cubed, so no, leave it alone. Okay, so we need strategy on how to go to cubic inches. Well, one way is to go kilometers to meters, meters to centimeters, centimeters to inches. Okay, so let's go to meters. Meters to centimeters. Now I'm going to go from centimeters to inches. Okay, so this is another cubic one. So you can do it one or two ways. You can do it, work out the cubes individually and put them in, or you can just do it as you're doing the calculation. Looking at how many sig figs for our answer? 2. Now, again, you're gonna have this conversion sheet as the last page of the test. So if you want, you can rip it out as soon as you get it, or you can leave it in. When you turn it in, don't staple it back onto the test. Now, the take-home problem, as I was driving to work today, I went, shit, I forgot again. So I'm gonna do it during lab. It will be posted during lab. Ah. Again, your take-home test needs to be done before the test. And you're gonna turn it in, and when you staple it to the back of the test when you turn it in, okay? All right, so I think that's all the example problems. Are there any other example problems you'd like me to do? Really done a nice variety. Now, your lab 2 is a wonderful way to study for the test as well as lab 1. Your test is basically a combination of lab 1 and lab 2. So if you feel comfortable with those 2 labs, you should do fine on the test. I'm looking at plenty of time left. So I'm going to pull up a practice test and show you what a pass test looks like.
Up 9.2.
I don't know. Yes, I would. Because it's a 5. And that's exactly right. Good. Once again, Ferguson human. Okay, so let me pull up a review. Are there any other questions before I pull up that test? Okay. All right. Let's see. This last problem is a very interesting problem. It is a true problem. My dad was stationed in Africa during Second World War, and the natives there did this. They did this problem. Okay, and notice part of the test, I'm giving you the version sheet. Okay. Convert each number to scientific notation. Sounds like dry lab 1 to me. Okay, so that's going to be okay, so it's got 2 sig figs, zeros not significant because there's no decimal place. So we need to make sure the precision is maintained from one to the other. All we're doing with scientific notation is renaming it. So the number and the precision need to remain the same. Okay, so that's 3 sig figs. One hundred. How many sigs is 100? How many sig figs?
1.
1. Zeros count if there's a decimal. There's no decimal. If there was a decimal there, it'd be 3. So we're looking at okay. So 1 sig fig for our scientific notation.
It would be 1.00 times 10 squared, right?
No, because that would be 3 sig figs.
No, but if there was a decimal.
Oh, yeah,
100
right.
decimal.
Exactly. Yeah, his point was if there was a decimal point there, it'd be 1.00 because we need to get 3 sig figs out of that. Scientific notation is very handy for significant figures. Adding zeros when you need to or taking them away. Where if you're not using scientific notation, you're much more limited when you convert. So scientific notation is your friend. Unless sometimes like in Dry Lab 1, we had answers that were like 10 to the 0. To me, I think that is more awkward than 2. 10 to the 0 if you want. Or not. Any number to the 0 power is 1. 1 million to the 0 power is 1. Anything. George to the 0 power is 1. Okay, count the sig figs. So we're looking at beginning zeros never count. So we're looking at 1, 2, 3, 4, 5, 6. Zeros in the middle always count. So we're looking at 5. Zeros at the end count only if there's a decimal. There's no decimal. Well, it doesn't say, it just says how many sig figs. But good catch though. Always check that kind of stuff. Yeah. Put infinite on which one?
Like conversion.
You want to have.
No, if I ask for a conversion, I mean, that's a really good test question. Like 1 inch equals 2.54. What are the sig figs on that? Infinite, because on your conversion sheet it's boldface. So it's, yeah. I mean, just, that's not a bad test question, though, actually. No, I won't add it, but I actually, for next fall semester, I'm gonna put that in.
Okay, good.
No, it's really a good test question. Thank you. After I understood it. Okay, convert these to 3 sig figs. That means we go to the fourth significant figure, which is a 5. That makes the 4 a 5 then. So we're talking about 56.5. Go to the fourth place, 1, 2, 3, 4. Okay, that means 0 to 4, we drop it, so it's 8.90 into the 8th. Notice when we do sig figs with scientific notation, the exponent doesn't come into play at all. It's just there to tell you how many times 10 you divide or multiply by. Okay, in this one, we have 1 million and a decimal point. So this is going to be tricky. Okay, so if we go to the fourth place, it's a 0. That means we drop everything, right? But we have to end up with 3 sig figs. As this sits, how many sig figs is that? 7. Why 7? Decimal point, right? Yeah.
Could we remove the decimal point and just put 1,100,000 or 110,000 as the answer?
No. The reason I'm saying no is because the decimal point signifies a certain level of precision. If we take it off, that precision goes from 7 to 1, which is just a really, really inaccurate number. So you have to leave it. So what is our savior? Scientific notation. So that'll be 3 sig figs. So his question was a good question. What if we just took the decimal point away? Work the problem. Much easier, huh? And again, it has to do with precision. The decimal point signifies a certain level of precision. Once you remove that, that level changes. You've got to maintain the level of precision, significant figures, as you manipulate these numbers. Good questions, you guys. All right, calculate these guys. Now, Word doesn't do fraction bars very well at all. So down here, I have a slash and I tell you it's division. Previous tests, I did the same problem and everyone multiplied it. It was like, that's why I put the division in to make sure you understand that's a division problem. Okay, let's look at this. We have 5 sig figs. And we have a whole bunch here, 2, 4, 6, 8. So our answer is going to have 5 sig figs. Okay, so that's more than 5. So let's go to the 6th place. Now becomes wait a minute here. Okay, another multiplication problem. So we're looking at 2 and 6. So our answer is going to have 2. Okay, so go to the 3rd place. And that kicks that up to a 1, the 0. And the division problem, we have 5, 6. So our answer is going to have 5. Now you can write little numbers above yours as well. And you don't have to erase them. You can just leave them there if you want. I do it for clarity, so you understand what's going on. And you can do it that way too. Same with the SF. You want to write 3SF or whatever, you're more than welcome to do that. I want it to be as clear to you as possible. Okay, so we're looking at 5 sig figs. We go to the 6th place, which is a 2, which means we drop everything. Okay, so that's kind of dry lab 1 stuff. Huh? Okay, conversions, kilometers to feet. The easiest way to do is to go kilometers, meters, centimeters, inches, feet. Would be one way, probably the way I would suggest it. Yeah,
What are we doing?
I said less.
Could we?
Oh, I was sneezing, he said bless you.
I have a question.
Yeah.
Why don't we just do it from kilometers to miles and feet? Rather than going
Yeah.
to inches. Oh,
there's always probably 3 or 4, routes. And you get up to the same answer, as long as you're careful on what is infinite sig figs versus which are not. Because then you get rounding when you have, for example, miles to kilometers. That's not exact. So that means it's 4 sig figs. So that's going to affect. And if you don't go that route where you're determining sig figs and use only infinite sig fig numbers, your answer will be more accurate. That's not to say once you round, it's not the same answer either. So, but your way is fine. You want to use let's do your way. Okay, so what way did you want to go?
from kilometers to miles and to feet.
It was 1609. Okay, then there's 5280. That's one way. The other way would be going from meters to meters. Meters to centimeters. Centimeters to inches. His had one less step than mine. Same process though, unit cancellation. The only problem with the first one is you have 4 sig figs here. On one has everything is infinite sig figs. So slightly more precise. But when you round to the final answer, you could end up in the same place. Yeah.
So. Where it says 4.5 kilometers equals blank feet, you could write in the blank spot 1.5 times 10 to the 4th feet. If you want.
Say again?
In the blank spot where you're wanting us to put the answer,
Yeah.
we can put 1.5 times 10 to the 4th feet.
Yeah, you mean instead of putting it over here on the.
No, I'm just saying like we can put times 10 to the whatever power there. We don't have to give the exact number of feet in this long.
Oh, yeah. I mean, after you round and all that stuff.
Yeah,
Yeah, that's fine. Okay, years to minutes. And again, these are all, really straightforward conversions. So I didn't want to do this. We could go years to weeks. We could go years to days. It doesn't matter. You're all going to end up in the same place. Just use as many infinite sig figs as possible, as opposed to non-ones, so you don't get rounding issues. So which way you want to go?
Year to date.
All right. Okay, once we get days, I'm gonna go to. We have hours. The other way would go years to weeks, weeks to days. Yeah,
We create our own conversion factors in order to shorten the process. For instance, I know that there's 1,440 minutes in a day. Can we use that as a conversion factor instead of having to write day to 24 hours, an hour to 60 minutes?
that always comes up. With that example, yes, but sometimes in the metric stuff, people make these huge jumps. And the problem is if the answer isn't correct, it's hard for me to follow their logic. So that's the only caveat about doing that. But yes.
Yeah.
Some of you are very comfortable in these conversions in math and others aren't. I'm just showing you the easiest way to validate your answer. Okay, ounces to milligrams. Okay, so what are we gonna do in that one now?
Ounces to pounds. Great.
I mean, we can go, ounces to pound, pound to grams,
Right.
and then grams to milligrams. Okay, so we're gonna go, so get this into pounds. And from pounds, we can go to grams. And grams to milligrams. That way everything cancels. Leaves us with milligrams. You could also do, instead of 1,000 over 1, you could also do 1 10 to the minus 3 grams. Those are equivalent. People don't like negative exponents. So that's why I did the other one. But both of them will work fine. Okay, so those are pretty straightforward, just conversions. All right. Now this is very interesting, this last problem here. And my dad started World War II in North Africa. And then he followed Rommel's retreat basically up into Germany. So we went from North Africa, Sicily, Italy, southern France. When he was in North Africa and Sicily, this is what they would do. Very clever people. They would take a $20 gold piece and it had 30.0926 grams of gold in it. Now, to be recognized as $20, you've got to be able to read it. So what they would do, they would grind off the gold till it's almost unreadable, but still readable. And they would collect the gold dust and then go cash in the $20 gold piece for another one. They kept doing that. which is illegal in the United States because you're not supposed to adulterate federal property, and coinage is really owned by the government. But anyway, that's what they did. So the problem here is, I'm saying if a gram was removed, gram of gold dust, and the United States minted 445,000 coins in 1933. How much money did the government lose, assuming all those coins were modified? A lot is right. Now, the current price of gold is higher than 1798. In fact, curiously, because it's been going up a lot because of the tariffs and all that stuff. Let's see what it is here. Yeah, it's at 3405 right now. So it's up a lot. Okay. The question in my mind is always, should I invest in stocks or precious metals? And my financial advisor did a bunch of stuff and she says, precious metals are flat. Stocks are going like this. So I listened to her and my stocks, because I bought really solids like IBM and some really solid stocks, they did okay. They stayed flat, but they didn't go down either. So, but you can see gold doubled. So, okay, so how do we do this problem then? Now the tricky part in this is what's the given? Sorry, say again?
1798 per ounce.
That's a conversion factor, converting ounces to money. Well, what's given?
440.
No, what was it? What did you say? No. How much? This is the tricky part of this problem is, and after that, it's just to grind out a bunch of conversion factors. What were you gonna say? Oh, you looked like you were about to. Okay. How much gold per coin did they get? Yeah.
Is that the given?
Okay.
5,500. It's 1,000 grams. 1 gram point.
Yeah. 1 gram per coin they removed. So what's the given? Okay, so we'll start. All right, so. Okay. But it's not really 1 gram, it's how many grams total?
That'd be, the first conversion would be $20.
So we have 1 gram per coin and we've got 445,000 coins at 1 gram a piece. That's a lot of gold dust. Yeah, I mean, this is kind of. I don't know how many they did per day. My dad is long passed, so there's no way I could ask him, but that'd be interesting to look up. Okay, so basically, that's how much grams of gold we ended up with after all the grinding and all that stuff. So how much money is that? Now, this is money that government loses. Yeah.
We would make a second conversion factor with the number of.
So the money's in ounces, right?
That would be,
Be trying to get rid of coin, right?
yeah, we're trying to get rid of coins, so it would have to be. Because there's, oh, it's 30.0926 grams per coin. So would we put the 30 point blah 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 over 20? Or no? No.
Let's just,
Over one for reconverted grams. And then we could.
yeah, we need to get into ounces because that's how the money is.
Right, yeah.
So, let's go there. Now, see, in my opinion, this problem was too hard for the test because you needed more time. This would be too easy for a take-home problem, but too hard for a test. So, but anyway. Yeah, let's do that. We're gonna go, okay, so we're gonna go grams to pound. That'll get us. It doesn't, the problem, okay, let's do, we're gonna end up with grams, right?
No.
So really we have 445,511 grams, right? If we have that many coins. So let's use that as a given. Assuming we took 1 gram off of each coin. That's how many grams we'd end up with. Okay, now let's go pound to gram, and that's 453.9. Okay, now we're in pounds. Let's take it to ounces. And then let's use today's price, which was 34.06.
Actual access. Oh, great. Yeah.
Hmm?
Yes, at first, and now it's like $36.
Yeah, but it's
Yeah,
3,406.
Yeah.
Okay. That's why I erased it. Okay, let's see how much money the government lost. And sig figs, let's go 4 now. So that's $53 million get lost in today's money by that practice. It's a cool problem, though. The biggest thing that people missed in this problem is they started off with the wrong given. Because they assumed that all the gold was consumed. Instead of just a little bit, yeah.
Why do we use 3,400 fixed dollars rather than the 1,798?
Oh, actually, I looked up today's price.
So we're
that's-
using that one.
Yeah, that's the 3406. But as far as the problem is concerned, you would have put down 1798. Because that's what it was whenever I came up with this problem. And I did this a long time ago, so this is probably. Of course, the price of gold didn't change that much either for a long time, till now, then it shot way up, so. But yeah, having done this problem, you should have put down for the test, 1798.
So the first conversion factor that we did of the 1,000 grams multiplied by the cent or by the coins, or that's what's negated.
No, it's not negated. All we did is we did the calculation and brought it down. Is this 1 gram for each coin? How many?
8 points a gram.
Yeah. Then we didn't have to get rid of that coins unit.
Technically, they're. The coins.
Well, that's significant.
And this is not.
Well, the reason why we could do pounds and then pounds to ounces.
Yeah.
That would be fine too. As long as your conversions make sense, that works. So there's probably, 3 or 4 different ways to do this problem. But it's all in which conversion factor you're using. As long as you use unit cancellation, it's fine, yeah.
Do you practice problems of stuff just like this? In Canvas?
Yeah, it's called TriLab 2.
Okay,
TriLab 2 is half. I would say 2/3 of this test is TriLab 2. Now, this problem, I'm just telling everyone, is too complex for an hour test.
So we won't see you cut like down a bit.
No, you're gonna have a problem, but it's not gonna
Be
be,
like this.
this problem has got some ambiguity in it. Because most people that missed this problem, didn't come up with the right given.
We all tried it and no, we still think it's a given.
Right, all everyone was giving me givens and none of them were right.
He gave you
Because
that
most
option.
Most people assume they ground up the whole coin. And they didn't, they just took off enough to make it legal tender. Which is very clever. Super illegal, but very clever. So anyway, and this is a true story, that's why I thought it'd be kind of fun to put it as a problem, but. Okay, so basically your test Tuesday is gonna have a bunch of conversion problems. Anywhere from, 1 step to many steps, and then a more complex problem. Like this one, but not. Hopefully not as ambiguous in certain aspects to this. More straightforward. Okay, anyway, that's what your test is gonna look like. It's actually gonna look a lot like this as well. So what I would probably do is. Take this test and change the numbers in the units, yeah. Same amount, yeah. So you're gonna have this plus your take-home test problem. That'll be worth another 20 points. Just can't give me anything. Canvas, yeah, in fact, let me show you, we're gonna go Canvas, Files, test related, and
bringing this in with us into class.
Yeah. Yeah.
And print it out.
and so here's a take home from last summer. Well, this was the example I'll give you in yesterday. So you go through here, cross off all the assumptions that were not useful. Some could be useful, so don't cross those off. But the ones that are obviously not, this has to do with carbon dioxide in the United States in the year 2011. So, glucose conversion and combustion in mitochondria, that's really not very valuable. By the way, this is an interesting this metric ton. Metric ton is 1,000 kilograms. So which is smaller than the normal ton. Pounds in a ton. So, but anyway, it's many of my Chem A students have never seen a metric ton, and there's a big T and a little t. If you see it abbreviated. So typically little t is a metric ton. I spell it out instead of letting you figure out, well, is a little t the metric or the big T? I spell it out. Gallons of gasoline per tank. Yes, because we're talking about cars. Leave that. Gasoline formula. Now, one take-home test I gave for test 3 had to do with ice being made in a plane through combustion. One of those white trails you see behind planes. Yeah, what's a contrail? Huh? It's water converted to ice. That's small crystals that are floating. Combustion process produces two things. It produces water and carbon dioxide. So if you're burning jet fuel, which is just H18, you're producing so much water. And because you're so high, it immediately turns to ice. Okay, so tomorrow morning, I want everyone to do this. When you go out to your car and start it, I want you to run around and look at the tailpipe and see what's coming out of the tailpipe. And then wait a little while and then notice it again. Because what's going to be coming out of your tailpipe? Water. And the reason why it's liquid water, because it isn't hot. When your tailpipe heats up, it turns to steam. And that's why it looks like nothing's there. But water is there coming out. It's real interesting. Everyone, sometimes my father-in-law had a shop in Sacramento, Amber Automotive. When people would take their car in thinking there was something wrong, they said, "There's water coming out of the exhaust pipe. Is there a leak in my radiator?" It's 2 + 2 is with them is 5. And then you have to explain what it is, But it's interesting. Most people don't know what that is. Of course, you'd always take a sample of it and analyze it. But if you know what's going on chemically, you don't need to do that. Anyway, that's what I would do today. I made it through the practice test. I was hoping to do that. Okay, so in lab, we're doing 2 things today. We're doing lab drawer checkout, and then we're also doing dry lab 2. And again, dry labs, I'm going to tell you, if you feel comfortable doing the labs at home, do them at home. And I'll be here for the duration. Okay, any other questions or any lingering questions? All right. Your official is. Yes, I need to give that to you. I was wondering why you're sitting there not taking notes.